Okay, to further calculate that, it was 6.68, ne? 6.8. Calculate the distance between the intersection of F with G and the intersection of the asymptotes of F. So they want us to calculate the distance between those 2 points. So to calculate the distance, like I said, we're going to use the distance formula, right? So we're going to say the distance between those 2 points, we're going to say is equals to x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. So let's go back then to that graph, you see. So that means your graph's supposed to be correct. Because you see, you're going to affect a lot of questions moving downwards. You understand? But nonetheless, even if, yeah, but the thing is, if you didn't know, this is okay because you can just take these coordinates. But the problem is gonna be here. You're not gonna know where's the intersection of this as these two graphs, graph of G and F. They intersect here. So it's 0 is to 0, and then we're gonna use 2 is to 1. All right. So remember, we have 0 is to 0, and we have another point which is 2 is to 1. So I'll call this point 1, I'll call this point 2. So point 2, x2 is equals to 2, x1 is equals to 0 squared. Y2 is equals to 1, y1 is equals to 0 to the power of 2. Oh, let's not forget this and this. And therefore, let's see how much are we going to have. For the 4 plus it's gonna be 5. We're gonna have root of 5, right? So that's the distance between the two decimal places. It's my calculator. Root of 5, we get to two decimal places, we get 2,24 units. We don't know whether it's meters or what. Just so we write units. So yeah, so that's how we solve 6.8. Now 6.9, it says to us, the graph of G intersects F at the point K, whereby K is 0 is to 0. The graph of G intersect, yes, you see, now it confirms that we do the correct answer, which means this point here, they say it's point K, whereby graph of G intersect with graph of F here at this point. See, that means our graph is correct. That's how you can also check your answers, man. Don't be that person who says, I'm just writing the answers, but you don't even understand what you're doing, right? So 6.9, we are told that the graph of G intersect F at the point K, which is 0 is to 0. So they want us to determine the K image. This is K prime. K prime means K image. Okay? Determine the K prime, the point of intersection. Oh, okay. This is what is happening here. Let me try to draw that portion only. Remember, graph of F goes like this, and then graph of that asymptote comes, that arm of hyperbola, like there is another one here, comes like this, and then here's the point of intersection. So this point, they say it is point K. Ne? So they want us to determine the new graph. If the point of intersection, there is a new point of intersection, which is going to be this. So if the graph of F, remember here we are affecting the values of X. If we have F at X is equals to 0, then, not 0. F at X, you see here, at F at X, our graph, F at X, our graph is here. But F at X minus 3, so that means we're going to shift our graph 3 units. When it's negative, we shift it to the right. So meaning we're going to shift our graph 3 units to the right. 1, 2, 3. So meaning 3 will be here. It will be here. And therefore, this is graph of what? This is us shifting the graph of F. And do not forget, the graph of F, it is which graph? Let me see. It is hyperbolic graph, meaning it's going to be this part. This one, see, it has shifted 3 units to the right. And then we're going to shift the graph of G again, which is this one, the exponential one, which is the G. So we're going to shift it also 3 units as well, right? So when you shift this one 3 units as well, meaning it's going to look like this. Our exponential, man, our exponential, let me fix that. Highlight now. Our graph will now look like this. Will look like this. See our exponential. We also shift our exponent G 3 units to the left. So remember, we also have this arm over here of a hyperbolic function, right? So now what is the new point of intersection? What will be the coordinates of this K? So the coordinates of this K, we're just gonna read them from there. We're gonna say the coordinates of K prime, which is K image. Our X, it has changed now, it's 3. And then our Y there is going to be how much? It's still going to be 0. Because we affected only the values of X. We didn't affect the values of Y. We affected inside of X. So that's how we go about for this one. This one is very simple, in fact. And then 6.10 for 1 mark again. Here's the deduction question, 6.1.10. This is the deduction question. They say to us, for which values, they're not saying value, for which values of X? This is a deduction question. These questions are simple. I don't know why people like to say these questions are difficult. For which values of X is f of X multiplied by g of X is greater or equals to 0? Hold that thought right there. I'm going to teach you this, and I'm going to teach you once. And you must master this. F multiplied by g greater than 0. Okay, we want whereby f at g multiplied by g at this is greater or equals to 0. So we want the values of x, ne? We want the values of x. Here's the condition. Okay, I just want to remember it again. Let me make this clear and listen to me if maybe you think this kind of questions, they give you problems. F of x, it is the yellow graph. G of x, it is the green graph. So we want the values of x, whereby we multiply these two graphs, we're going to get something that is positive, something that is greater than 0, it is positive, right? We want, when we multiply these two graphs, we get a positive number. But what is f of x? F of x is the same as y value multiplied by g of x is the same as y value. Remember, f of x is this is a y. It's the same as y is equals to 2 over, right? It's the same as y value. You get my point? So it's the same as saying multiplying the y values of f together with the y values of g. So what you're gonna do, ne? You're gonna do it like this. To get a positive number or something that is greater than 0, you're supposed to multiply positive by positive. You get a positive, right? Or you're supposed to multiply negative by negative, and then you will get the positive. So you go to your graph. You're going to look for the y values whereby for f and g, we have the positive y values. So now, above this line, here, at this part, let's focus that side for now. The values of y are positive. For g as well as for f, we have positive y values. Above x-axis, we have the positive y values. You get it? So when we start from here at the origin, which is from 0, and then we move in this direction, here, when x becomes less than 0, what is happening? When x becomes less than 0, our graph of f goes like this, and our graph of g goes like this. So the y values for this yellow graph and the y values for this green graph, starting from 0 and moving like this, they are both positive. So meaning when x is less than 0, this condition holds. Which condition? We can see that when x is less than 0, we have the y values that are being multiplied together with the y values, right? All right, sharp. Now let's move in this direction. Let's move in this direction then. Let's move in this direction. When x becomes greater than 0. When x becomes greater than 0, what's happening? Look, when x becomes greater, we have negative y value for this graph. We also have negative y value for that graph. And when we multiply them together, negative y multiplied by negative y, we get something greater than 0. We get a positive, we get a positive. Do you understand? So meaning this condition, this case meaning it also applies. It gives us a correct answer. But now here's the thing. Ne? Here's the thing. How are we going to put it down? And what is the thing that I'm actually talking about? We have an asymptote here for this yellow graph. So meaning we're going to end where asymptote restrict us. This is a restriction. We're going to end here. So that means this part only is the one that continues, yeah, exponential. But this one, yeah, hyperbola, it ends here. So that means because of this asymptote, we're going to end here and move backward. So meaning this condition, f at x multiplied by g at x is greater than 0. It is when x it becomes less than 2. This will be the final answer. So when x is less than 2, look, go to your graph. This is 2. Don't forget our asymptote here is 2. So when x becomes less than 2, we have negative multiplied by negative. We have negative multiplied by negative. We have 0 multiplied by 0 because remember 0 it is also included. We get 0. We have positive multiplied by positive. We have positive multiplied by positive. We have positive multiplied by positive. We still get something that is greater than 0. So when x is less than 2, but when x is greater than 2, we can see that our graph now of f, it has positive y values. Our graph of g, it has negative y values. So negative by positive, it won't give us something that is greater than 0. So the final answer to that question, we're going to say it is whereby x, it is less than 2. As I say this is when I close this question. But do we understand? Closing a question is fine, but do we understand? I don't mind repeating whatever you want me to repeat. Just feel free. Remember, you are doing this for yourself, not for someone who's attending here with you. It's for yourself. Do you understand? Do you hear me? Do you get me?
Yes.
Yeah.
They sure, guys?
Yes.
Yes.
You get me 90% or 100% or 80% even?
100%.
100.
Lego, are you sleeping?
No.
Okay.